Hey, Mr. Dodd here again. Solving basics. We're going to talk about solving. Um, I can recognize the number of solutions for a function. Um, Basically, this is pretty straightforward. The number of, well, pretty straightforward. There's just some disguises that I want to give you guys a heads up on that you may or may not see as time goes by. And then the other thing, I mentioned this in the overview, but anytime there's a potential of dividing by zero, there could be an extraneous solution. So we need to make sure we note that from the very beginning. So I'll make sure I do a good example or give a good example of that as we go through. And then the skills, step one, algebraically eliminate anything that could deceive. So variables on both, or on the bottom, variables on both sides, non-combined terms, that are like terms, parentheses. There's just a bunch of stuff that you'll see that might come up. Find the degree, like we did in the background information, and then first degree has one solution, second degree has two, third degree has three, so on and so forth. So as far as we're concerned today, that's what we're going to go with. So I'm going to show you these examples. Feel free to pause at any point if you want to try any of these. In fact, you can try them, pause right now, and try them without any of my examples as well. So you're welcome to do that. But the first one, I'm going to make sure that I note x cannot be equal to 0, because if it was, I would be dividing by 0 in the first step. And then I want to make sure that I get that x out of the bottom first. So the way we would get an x out of a bottom is by multiplying everything by x. So if I distribute this x to all my terms on the inside, I'd be left with 1 plus 3x squared minus 4x equals 7x. Just to combine my like terms to make sure I'm being safe, I'm going to add 4x to both sides. So 1 plus 3x squared equals 11x. So all my like terms are combined. There's nothing that could be tricking me at this point. I look at my degree. I see, oh yeah, look, it's a second degree function. So that means I have two solutions. Okay. So that's the first major way. Next one. I would again notice I have a single x in the bottom, so x cannot be equal to 0. And then if I divide these out, x cubed and x squared simplifies to an x plus 5x equals 2. 6x equals 2. All my like terms have been combined. I have nothing that I can do other than divide by 6. So I know I'm going to have one solution to this particular problem. Okay, parentheses is the next thing here. So x squared plus 4x equals 11. Nothing to combine there. So simply just say, oh, I have a second degree, so I have two solutions on that one. Okay, same thing with parentheses over here. So x squared plus 4x minus 7 equals x squared plus 3x. So you might look at this and see, oh, I have squareds, so that means I have two solutions. But remember I said make sure you combine all your like terms. So I'm going to subtract 3x from this 4x, and I'm going to subtract x squared from this x squared. And that leaves me with x minus 7 equals 0. So actually when I combine all my like terms, I only have x to the first power, so this is one solution. Okay. This is a big deal just because if you know how many solutions you have, you'll know what techniques you have at your disposal, and then you also will know what your end goal is. So as we go through, just this is a really good idea to be able to figure out how many solutions there are based on that. So hopefully that helps your understanding.